So this is the first PowerPoint in Chapter 9, and it's going to introduce a concept called stoichiometry. So what stoichiometry takes advantage of is that whole idea of the mole to mass relationship. We've talked about this a lot. We've done mole problems with this where we go from moles to grams, etc. But what stoichiometry does is it studies the quantitative, meaning numbers, relationships between amounts of reactants used and products formed. So it's kind of saying in any reaction, what is the max amount of product you can get from the reaction, or what is the maximum amount of waste you will have. And stoichiometry is actually a very practical application. It's used in all kinds of chemical and manufacturing businesses because they want to make the most amount of product they can using the least amount of materials and having the least amount of waste left over. So in any kind of corporation like that, like DuPont, for example, they will have a department where they basically are doing stoichiometry all day long and figuring out how efficient the plant is, etc., and so forth. This is based on the law of conservation of mass, which we've learned a bunch of times this year. We've discussed it a bunch of times. It's the idea that matter or mass is neither created nor destroyed during a reaction. It only changes form. Even though the bonds break, new bonds form, new products are formed, the mass of the reactants always equals the mass of the products. And the number of moles of each atom are equal on both sides. So stoichiometry is very heavily math involved. We're going to do a ton of math, a ton of practice problems, but the good news is I've actually started you on this path before you even knew it, before we even got to stoichiometry. Stoichiometry involves those tic-tac-toe board, those those type of factor label method. So we'll start with problem 1. It says the combustion of propane provides energy for heating homes, cooking food, and soldering metal parts. Interpret the equation for combustion of propane in terms of representative particles, moles, and mass, and show that the law of conservation of mass is obeyed. So one thing about stoichiometry is you always must start with a balanced equation. Always, 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 always. You have to know what the relative mole amounts are. Sometimes you'll be given the equation balanced outright. Sometimes you'll be given the skeleton equation and you have to balance it. But it's important that the first step always, the first thing you do is you have a balanced equation. Here you see the equation balanced. The coefficients are in red. So basically this problem is asking you to kind of interpret what those coefficients in red mean. And what you can use those coefficients for is how many moles of each thing there are, and also how many molecules. And that may be a little confusing that they're interchangeable, but they are. So when it says 5 moles, you see the red 5 in front of O2, that means that there's 5 moles of O2, but there's also 5 molecules of O2. And you see the rest of the equation, 3 moles of CO2, 4 moles of H2O. And then remember, if you see in the balance, there is no 1 written in front of propane, but 1 is understood, so there's 1 mole of propane. What we're going to do with these balanced equations and these mole amounts here is we're going to do like ratios. So what this is saying is for every 1 mole of propane, you need 5 moles of oxygen. So you need 5 times as much oxygen to react with propane. Same thing over here. When you have 1 mole of propane, you're going to get out 4 moles of H2O. So for every mole of propane you burn, you get 4 moles of H2O. And that kind of ratio, those coefficients, is what we're going to take advantage of in stoich. And then the last part of the question is calculate the mass and prove that the law of conservation of mass is observed. So all I do is take those mole amounts that I got from the top. So 1 mole of propane, 5 moles of O2, 3 moles of CO2, and 4 moles of H2O. And all I did is take them and multiply by their molar mass to get the actual number of grams. And I have 44 grams of propane, 160 grams of oxygen, 132 of CO2, and 72 of H2O. And then to prove that the law of conservation of mass is obeyed, I add up all the mass of the reactants, add up all the mass of the product, and they should be about equal. So this is just showing you that the law of conservation of mass was obeyed here. Again, stoich takes advantage of mole ratios. Remember, ratio is comparative. It's comparing, apples to oranges, boys to girls. It can be written with the 2 dots, or it can be written as a fraction. But a mole ratio is the ratio between the numbers of moles of any 2 substances in a balanced equation. We are going to use coefficients for our ratios. The coefficients tell us the number of moles of each. That is why you have to start with a balanced equation. Because if those coefficients aren't balanced, if they're not right, then your mole ratio is wrong and then your whole problem is wrong. We're going to use those mole ratios within the factor label method within the tic-tac-toe board to compare reactants and products. So let's do a full Stoich problem. It says one disadvantage of burning propane is that carbon dioxide is one of the products. The released carbon dioxide increases the going concentration of CO2 in the atmosphere. How many moles of carbon dioxide are produced when you have 10 moles of propane burned in excess oxygen? The excess oxygen part means that the oxygen is the one that's going to be left over. There's just extra, which makes sense because it's burned in air, so there's always going to be oxygen in the air. Your first step, again, is to balance the equation. You must always start with a balanced equation. Sometimes it'll be given to you, and then you can kind of just skip that step. One other thing that helps, I find, is when you label what you're given in the problem either on top of the equation or on the bottom. So when it says you have 10 moles of propane, you write 10 moles, so you can kind of keep track. And then it says how many moles of carbon dioxide, question mark, moles. So what you're going to do here is you're going to say, okay, what is the relationship, what is the ratio of propane to carbon dioxide in the balanced equation? Well, it's 1 to 3. So if the ratio is 1 to 3, well then, if you have 10 moles of propane, how much CO2 would you get from that? And you can see kind of logically that it should be 3 times the amount. But again, we're starting with the easy one to practice. So first you got to determine the mole ratio. This step you don't always have to write like this. You can just do it in your head to determine the mole ratio. Remember that the ratio of moles comes from the coefficients in front of the products or reactants. So we have 3 moles of CO2 that comes from right here. 3 moles of CO2 and 1 mole of C3H3. Again, this step you don't have to write out. You can just kind of do it in your head. So what you're actually going to write for me is you're going to start with the factor label method. Start with what you're given. So in the problem you're given 10 moles of propane. So that's where I'm starting. Notice I write moles of propane because I need to now know exactly what substance I'm talking about, because what you're going to do is set up the mole ratio. This right here is the key to Stoich, this mole ratio. A mole ratio is always going to compare moles and moles. The units will be the same. What's going to be different is what thing they're talking about. So this one's moles of CO2 and this one's moles of C3H8. Notice moles of C3H8 and moles of C3H8 are opposite of each other. That's the rule. Remember, if you want to get rid of something, you put it opposite. That's why I have to put moles of what here. And then you do 3 moles of CO2 on the top. Remember, this 3 and this 1 came from the coefficients of the balanced equation. Then I just multiply and I get 30 moles of CO2. So what this is saying is, according to this ratio, 3 to 1, if I have 10 moles of propane, I need 30 moles of CO2, which is 3 times as much, which is what the ratio tells us. Next problem, determine the mass of sodium chloride produced when 1.25 moles of chlorine gas reacts vigorously with sodium. So I have my equation. I see that it's already balanced, so we're good to go. And then notice what I write, what I'm given in the problem. 1.25 moles of Cl2, and I'm looking for grams this time of NaCl. Then either in your head or write down, you compare what the two things. So you say there's 2 moles of NaCl, coefficient, and 1 mole of Cl2. In this case, the sodium's just not involved, so we just ignore it. Now, everything's the same. Start with what you're given. I'm given 1.25 moles of Cl2. Boom. Next is the mole ratio. The rule is, whenever you get a substance into moles, the next step is always the ratio. This is how you change substances. Think of it like a train station, or like, when you're connecting flights, you get off of one substance and you turn into a different substance. And the way you do that is the mole to mole ratio. Cl2 goes on the bottom so I can cancel, NaCl on the top, and then 2 and 1 come from the coefficients of the equation. Now, this would give me the answer in moles, but if you look, the question asks for grams. But we know how to go from moles to grams. I just do the molar mass of NaCl, and I get 146 grams of NaCl. So you actually can go from moles to mole ratio to grams, or you can either go grams to mole ratio to grams. I think that's what we're going to do on this one. So it says ammonium nitrate, an important fertilizer, produces N2O gas when it decomposes. Determine the mass of water produced from the decomposition of 25 grams of solid ammonium nitrate. Again, the first step of the problem, balanced equation. Have it there. I label what I'm getting, 25 grams of ammonium nitrate, and I'm looking for grams of water. So your first instinct may be, okay, let's use a gram to gram ratio now. You can't do that. It only exists as a mole to mole ratio. You cannot do a gram to gram ratio. So if you're given an amount starting in grams, before you can do the mole to mole ratio, you have to turn it to grams. So notice, see how I'm using ammonium nitrate here? I haven't changed substances yet. I'm just going from grams of ammonium nitrate to moles of ammonium nitrate. Once you're in moles, you use the mole ratio. Remember, this step you don't really have to write out. So here's my moles of ammonium nitrate. The next step is always the mole to mole ratio. I'm going to change trains. I'm going to change my plane. Moles of ammonium nitrate on the bottom, so it cancels. H2O, what you're looking for, on the top. And the answer was asked for in grams, so I just do moles to grams using the molar mass. You're actually going to do these on one long tic-tac-toe board line, so we're just kind of starting out. Now, the steps in Stoich, again, I'm never going to ask you the steps. These are kind of general for you to reference. It's more going to be, can you do the problem? But the most important one is this number one, write a balanced chemical equation. You must start with a balanced equation. Must, must, must. Usually you're going to be given at least the skeletal equation. Sometimes you'll just be given the balanced equation outright, but make sure it's balanced because you need those coefficients. Then you determine the moles given. You determine the moles of the unknown. The mole to mole ratio is going to be somewhere in there. And then for moles of unknown, you determine the mass using a mole to mass conversion. And that concludes this lecture.